Okay, guys, welcome back. We are actually going into Unit 5 today. Our whole theme is going to be based around polynomial functions. So we're going to go into Lesson 1, Section 5.1, Polynomial Functions. Please make sure you guys are pausing repeatedly and copying down these notes into your packet. A polynomial is an expression of algebraic terms, especially the sum of several terms that contain different powers of the same variables. Standard form is when the terms are in order from highest to lowest degree. So that is a main rule for today that we're going to use when we go down to example 1. So some of these expressions are going to be out of order, so we're going to learn how to put them in standard form. And we're actually going to label them by name after we put them in standard form. A monomial is when we have one term, binomial is 2 terms, trinomial is 3 terms, and the term polynomial could really mean any number of terms from 1 to, I don't know, as high of a number as you can think of. But we only have to memorize the terms up to 3. The degree of a polynomial is its highest exponent. So something that is just a normal number, such as the number 5 or whatever your favorite number is, that has a degree of 0 because it doesn't have a variable to have an exponent. Linear, such as 5x, is considered to have or considered to be a first degree polynomial because it has an invisible exponent of 1. I should say the variable has the invisible exponent of 1. A quadratic is such as 5x squared is considered a second degree. Cubic, such as 5x to the third or 5x cubed, is considered third degree. Quartic, such as 5x to the fourth, is a fourth degree. And quintic, a fifth degree, is an example of 5x to the fifth. So you have to memorize these things on the page: monomial, binomial, trinomial, and the degrees constant up to quintic. So we're going to use that information and go into the next part here, example 1. This is going to be the first part of the test. It's going to be write each polynomial in standard form, then classify it by degree of number of and number of terms. So we're essentially kind of like doing 3 things here. Now this guy in A is in standard form. It has a constant at the end. To be in standard form, constants must always be at the end because they have a degree of 0. So it's in standard form already, so I can go to naming it. It has 2 terms here. 1, 2. So it is a binomial. And it is its highest exponent is an invisible 1. So that means that is linear, according to the notes above. So we have a linear binomial. We have just classified it based on degree and number of terms. It's a linear binomial. The next one only has 1 term, so obviously it's in standard form. It has a degree of invisible 1, so we have another linear, but this time it's a linear monomial because it only has 1 term. Oh, by the way, if I didn't mention this, terms are separated by plus and minus signs. I might have forgotten that. So a very important detail today. Terms are separated by plus and minus signs. Letter C is our first one that is out of order. So it must go in order x to the third plus 3x minus 6. Highest degree to the lowest. So then its highest degree is 3, so we would call it cubic. And it's 3 terms, so cubic trinomial. Letter D is out of order. First would be negative 2x to the fourth. Now, here's the first problem where you can combine like terms. So that's a rule that's very important today. Do not reorder things until after you combine like terms. The 3x minus 3x actually eliminate. So you're not going to have x's anymore in the problem. So just bring down your plus 6. After you combine like terms, then you classify it by name. So the highest degree is 4, so that is quartic. And it's 2 terms, binomial. So again, please make sure you combine like terms if you can, and then name it at the end. Letter E, 3x to the fourth drops down. No x to the third. We have plus 8x to the second. Then minus 2x plus 7. There were no like terms there. Now this guy, highest degree is 4, so that's a quartic. And it has 4 terms, so what we're going to do is just call it a polynomial with 4 terms. Polynomial with 4 terms. Anything 4 and up, call it a polynomial with its number of terms. Anything 1 to 3, call monomial, binomial, trinomial. Okay, we do have like terms here in letter F. Minus 2x to the 6 plus 2x to the 6 is 0, so they cancel. So we're just left with literally the number 3. Since 3 is does not have a variable, we call it a constant. And it's just a constant monomial since it's only 1 term. Okay, so that was the end of classifying polynomials. Our second theme of the day is talking about end behavior. Now, the end behavior of a polynomial is if we were to graph it, what would it look like at the ends? So here, if we take a look, this guy has an end behavior of up and up, because we look here on the left, it goes up to infinity, and on the right, it goes up to infinity. This end behavior is down and up, down to the left, up to the right. This has end behavior of down and down. This end behavior is up and down. So left and then right, up and down. Now, we're not going to be graphing here. Our goal here is, in example 2, is we're going to determine which end behavior we're going to write down based on how the polynomial functions look. And so our answers are, all we're literally writing for these is up and up, or down and up, or down and down, okay? So here's how we're going to do it. End behavior is determined by degree and leading coefficient. For example, right here, this is let me highlight it here. This is the leading term. It's the term with the highest exponent. So what we're going to be doing is focusing on every polynomial, the term with the highest exponent. If they're out of order, in all of our problems today in my lesson, that's going to be the first term. But sometimes a worksheet or a test may try to trick you and throw it at you where the highest degree term is not in the beginning. But in my lesson today, they're all in the beginning. So that's our focus. We're just going to be looking at the terms that are the highest terms that I highlighted here. The other terms don't really matter for determining end behavior. So if I say that end behavior is determined by degree and leading coefficient, look back at example A, the degree is 3. That's an odd number. And the leading coefficient is a positive. So what it comes down to when we talk about degree and leading coefficient, the degree will either be an even or odd number based on the exponent, of course. And then the leading coefficient is the coefficient in the number in front, and that we look if it's positive or negative. So again, they refer to A, this guy here, they refer to A as being the leading coefficient. They refer to N as being the exponent. So we look at this table whenever we're doing these problems, and you'll want to memorize it, of course, but if the A is positive and the exponent is an even number, the N behavior would be up and up, such as this first one here. Notice we have a positive coefficient of 4 and an even exponent. So that is, as you can see right here, look at the table, it would be up and up. So if we take a look, what happens when we have N behavior like this guy here, notice that is a positive 1 for the leading coefficient, and the exponent is an even number 3. So that would be positive and odd. So that would be, we would write down and up, like it says below the graph. The third one, take a look here. Notice that we have a negative for A, the leading coefficient, and the exponent, the degree, is an even number. So that would be negative and even, down and down, just like the graph shows. And then lastly, the leading term here is a negative leading coefficient for A, and the N, the degree, is 3, an odd number. So negative and odd would be up and down, just like the graph shows. So our goal here, going down to example 2, is just simply to determine what the N behavior is. You have 4 options for each problem. So as I highlighted, I'm looking in letter A, by the way, down here, where the leading term is the A is positive and the N is an odd number. So positive and odd, that would be this guy here, down and up. So we're going to write down here, literally is down and up. So if we were to graph it, the N behavior would look something like that, down and up. Letter B, the leading term is negative 2x to the 4th. The A is negative, and the N, the exponent, is even. So A is negative and N is even. That would be this here, down and down. So we're simply going to write down and down. The C, the leading term is negative 3x to the 5th. A is negative, and the N exponent is odd, so that would be up and down. Moving on to D, we have positive for A, it's a positive 1, and the exponent is even. So that would be positive and even, would be up and up. Letter E would be positive and odd. Positive and odd. So that would be right here, down and up. And then the last one, the A is negative and the exponent is even. So negative even would be down and down. So memorize that table and you'll be good for the test. Okay, guys, that's it for my lesson. Have a good day. I would suggest you working ahead in the packet.